kq by r. So this would be kq1 q2 by r, right? Okay, and
Yes, sir.
then we understood that if we have multiple charges, right? So then this would be k q1 q2 by r1 2 plus k q2 q3 by r23 plus k and q1 and q, let's say 3 by r13 and so on. So these are for only three charges, and if we have four charges, so something like that, right?
Yes, sir.
And then what we did, and then we talked about the potential energy in the external electric field. So external electric field due to one charge, this was simply K or Q into V, right? This was
Yes.
simply that. And then we calculated, so this was one charge, and then we calculated two charges, right? So in the presence of external, so this was Q was Q1 V1 plus Q2 V2 plus K Q1 Q2 by R, right? So we had some electric field, and at this point Q1 was there, and at this point, and they had some separation R, and the potential at this point is V1, at this point V2, right? So then we calculated the potential energy like this. Understood? Sorry.
Yes, sir.
So this is what we did in our previous classes, right? And remember that potential energy is what? Potential energy is work done, work done to make the system, right?
Yes, sir.
So this arises due to interaction of two charges or interaction of charges with some electric field, right? So, and the interaction energy is stored in the form of potential energy, right? So that is what we call the potential energy. Now, uh, so let's say that if we have these right, these four charges, so this will also have to make to bring these charges at these corners. So it will require the energy, right? So that is called the potential energy, right? So this we already learned. Now we will calculate the pot. So this you have already learned. So now we will talk about potential energy due to dipole, right? So we have a dipole in the presence of electric field, right? So we have a dipole, and this is right. So let's say this was initially at here. So this was theta one, and then we bring it to this point, theta two, right? Theta two, and this is minus q, and this is plus q, right? So what we did is that first it was placed here at theta one, and then we moved this dipole with some angle, right? So it reaches here, and this angle is theta 2. So which force is doing the work? This we have already learned in your CPSC class, so I'm just revising that portion. Which work is doing the, which force is doing the work? If we are moving with some angle, right? So which force is doing the work? Or let me simplify the question more. So which force, linear or rotational force? Which force is doing the work?
Can you linear or
Linear or rotational? So which force is doing the work?
rotational?
Rotational, right? So the work done would be tau d theta, right? From theta 1 to theta 2. So this would be the work done, right? And when we simplify this, so because in this case, work is not F dot ds, right? From x1 to x2. Because the force are, so in this direction the force is there and in this direction force is there. So forces are balancing each other. Net force is zero. This is zero, right? So that is why no linear work done is here, right? So we only have a rotational work done, right? Sorry. So when we
Yes, sir.
calculate this out, so we get work done which is minus of p e cos theta 2 minus cos theta 1, right? So this is the
Yes, sir.
work done in moving the dipole from theta 1 to theta 2, right? And similarly, this is the change in potential energy. So this is equal to change in potential energy, which is W is delta U, right? And from this we calculate the potential energy which is minus P dot. This is the potential energy, right? Is this clear? So this you have already learned, right?
Yes, sir. Clear.
So this is the potential energy of the dipole.
This will be sin theta, right?
Sin theta, potential energy of the dipole.
Yes, sir.
Okay. So this is right. Tau is what? How can we define tau?
Rotational force torque.
Yeah. So tau is for in the presence of electric field. You have already calculated torque. Do you remember what was this torque? If you remember the previous classes, so what was the torque? Let me write it in the vector form. What was this?
P sin theta, I think.
Yeah, so good, absolutely right. So this was P cross E, right?
Sir.
So this is PE sine theta. Okay, so this is the magnet. And so this is minus here, right? So if we put
Yes, sir.
tau equal to P sine theta, right? So if we put tau equal to P sine theta, this is taken outside, and then when we integrate sine theta, so we'll got cos theta. So this become cos theta 2 minus cos theta 1, right? So this is how we calculate work done. So what should be here? Cos theta or sine theta?
Yes, sir. Cos theta is dot product, right?
Yeah, yeah. So this is the dot product. Yeah, so you are thinking in the right direction. So potential energy is the dot product and torque is cross product, right? So torque is
Yes, sir.
cross product and this potential energy is dot product. And we have a minus sign. So this minus sign represents that it is a bounded system, right? Yeah.
Yes, sir.
Oh, okay. So this much we know. So yeah, you already know, but for the revision, let us just note it down, just for revision purpose. I know you have
Okay,
already,
sir.
yeah, because whenever we repeat something again and again, then it becomes more clear, right? So, and yeah, so then this will be in our memory. Okay, so whenever I want to memorize something, I repeat that again. I write that again and again. So
Yes, sir.
in that way, yeah. Okay, so whenever you have noted this part, whenever you note it down, please
Yes, sir.
note it. Okay. So, yeah, let me check if you remember or not. Who is joining? Faiza. Oh, after so many days, Faiza is joining. Okay, so Faiza, mic is not working. Oh, yes. Yeah, hello, Faiza. Assalamu alaikum. Yes, I remember that you don't talk so much. So, yeah. Faiza, we are just, so you missed so many classes, right? So please don't do that. Otherwise, yeah, who joined again? Chavez is also joined. Good. Hello, Chavez. Assalamu alaikum.
Walaikum salam.
Okay, so Tarif, okay, sorry to, yeah, so I will repeat some things again and yeah, please.
Yes, yes, fine.
Okay. Yeah, so we are just calculating the potential energy, right? Chavez, you remember that we were doing the potential energy, right? So we did the potential energy, we calculated the potential energy of two charges, right? Without the presence of any electric field. So this was this. And then we calculated the potential energy due to multiple charges. So this was like this, right? And then what we do is that we put one charge in the presence of electric field. So then potential energy is this, right? And after that, we put two charges in the presence of electric field. So this is the electric field and we put two charges, right? So then this is the potential energy. So this up to this point, we did in the previous class, right, Shaviz?
Yes, sir.
So after that, we are calculating
Dipole
the
we did.
dipole, we didn't do, right?
Oh,
So yeah, in the CBC, yeah, so we only did up to this point. Remember, we did only this calculation. So up to this point, we calculated up to this point, right? Two charges and then this one. Okay.
yes.
So yeah, so now we are calculating the this part we have already done in your CBSE portion. So just for the revision, right? Because I was we were discussing, me and Tarif were discussing that whenever we repeat things, then it becomes more clear, right? So yeah, so the potential energy is just the work done to make the system, right? And this is also equal to change in. So work done is also change in potential energy, right? So for the case of dipole, which force does the work, Chavez? Which force does the work?
Torque, sir.
Torque, right? So a linear force, the overall linear force becomes zero. So total linear force, right? Because this is the force is in this direction and then this force in this direction. So they are canceling out. So linear force is canceling out. F net is zero. But we have, due to this dipole, we have a net electric, yeah, we have net torque, right? So due to this torque, we'll have some work done. So from this, we already know that what is the torque. This is P cross E, right? So this is P sine theta, and then we put the value and then calculate. So this is the work done due to the in the presence of electric field due to dipole, right? So the work done is change in potential energy. So we remember that the potential energy would be minus P dot E. So torque is P cross E, and potential energy is P dot E. Right. So this is why this cross product and dot product are important, right? So from vector classes, we already learned about the dot and cross product. So this is how we use this dot product and cross product. Okay, so now let us do one question which I guess you have already done in your CBSA class, but let me check if you guys remember or not. So we have a dipole of charge, let's say 5 microcoulomb is placed in the electric field of magnitude, let's say uh, let's say 200 volt per meter, right? Then what is the work?
Sir,
Yes, yes, Chavez. Yes, Chavez, are you saying something?
sir, can you scroll up?
Oh, you want me to? Where should I put the screen, Chavez? In here or in here? Where do you want me to put this screen? Yes, Chavez. Yes, Chavez. Is this okay?
No, sir.
Down. Okay. Is this okay? Yes. Is this
Yes, sir. More down, can you?
yeah? This one okay.
Yes, sir. Done, sir.
Okay. So a dipole, and did you get the notes?
Yes, sir. I got the notes.
Yeah. And if you face any problems, so please ask. Right. So yeah.
Yes,
A,
sir.
a dipole of charge 5 microcoulomb is placed in the electric field of magnitude 200 meter. What is the work done in rotating in rotating the dipole from stable to unstable equilibrium? So this, I guess, this question you have already done, but you guys please do that. And second question is that this is first question. Second is that what is the potential energy difference? And third one is that what is the potential energy at let's say 60? Okay. So I didn't give the distance of the dipole. So yeah. Uh okay. I should write. So dipole of charge or dipole dipole right, and remember this is only the magnitude. So let's say 3 coulomb meter. Okay. So yeah, please calculate and tell me guys. First 3 questions. This you have already done in your CBSE class. So I guess please calculate and tell. So P is given, right? P is 3 coulomb meter, and then magnitude of electric field is also given. So 200 voltmeter, right? And you have to find out what is the work done, okay, in rotating the dipole from stable to unstable equilibrium. So what is the work done, right? And in the second question, we have to figure out delta U. And in the third question, we have to find out. Is the question?
Sir, stable means 0 degree.
Yes, absolutely. So this is this is the critical information. So stable, right? We have this electric field. Yes, you are absolutely correct. So we have this electric field, and in stable equilibrium, this dipole is making a 0 degree. So this dipole is in here. This is minus Q and this is Q. So P is in this direction, right? And E is in same direction. So stable. Good. Yes. Stable is theta 1 is as Chavez said 0. What is unstable?
180 degree.
180 degrees. So if dipole is put like this, so dipole is put like this. So this is minus Q and this is Q. So P is in this direction, right? P is in this direction, E is in this direction. So we have 180 degrees. Yes, theta 2 is 180. Now we know work would be how much? Work would be simply minus of P E. One moment, guys. One moment. Yes, guys. Calculated everything. Yes. So who has got the answer? Are you guys? Yeah. Are you guys there? Yes. Faiza, Tarif, and Chavez. I thought you guys left. So
Yes, sir.
yeah. So did you guys find any answer?
Yes, sir, doing.
Okay. Yeah. So please calculate and tell. So in the so we'll have a Friday fortnightly test, right? So in that, yeah, Chavez, please come because yeah. So that would be just a practice, right, test. So please come in that test. So in that fortnightly test, I will ask the potential
Can you
and
repeat, sir?
yeah. So we'll have a fortnightly test in this Friday, right? So please take that test. So in that test, I will ask potential and potential energy due to different distributions. So in that way, your CBSE portion will be covered also, and this portion will also be covered. So yeah, in that way you can yeah, find out that how much you have prepared and which part you should work on. So you guys please Tarif always take that test, but Faiza, Chavez, sometimes you guys come and then sometimes you don't. So yeah, W is minus 600. So Tarif got minus 600. Right. Let me say in joules. So what did you guys Faiza and Chavez. So Chavez, what
Sir,
did you get?
calculate.
Yes, what did you get? Yes, Chavez, what did you get?
Calculating.
Oh, calculate. Okay, so let me calculate and you guys check. We have, right, we have work done which is minus of PE and cos theta 2 minus cos theta. And we know all the values. So this is
Sir, is it
my
600 joules?
600, right? So check the sign, Tarif or Chavez. Okay, Faiza, what is your answer? So this is 3 coulomb meter and this is 200.
Sorry, sir, it's minus 600.
Ah, minus. Okay, so you also got minus. Yeah. So this is theta 1. So cos theta is minus. So cos of 180 degree, right? Minus of cos of what? 0 degree. So this is minus 600 and cos of 180 is what? This is what, guys?
Minus 1.
Minus 1 cos 0 1.
Minus
So
2.
minus 600 into minus 2. So this is how much? 12
400.
1200 joules, right? So where did you get which part you guys missed? Yes.
So cos 90 over 0.
Oh, 90. No, we have stable and unstable, right?
I also took it as 9 currency as 0.
Yeah. So that is why I wrote, right? Stable to unstable, right, guys? Yeah. So in this way, yeah, we can. So that is why repetition is right. Because sometimes I also do mistakes, and when I repeat, so then I know that yeah, in that part I made a mistake. Okay, Faiza, what? Yeah. So did you understand this part? Okay. Now the second question, very difficult question, right? Very difficult. So what is the energy difference, right? So work done is equal to the difference of potential energy, right? So this would be simply 1200, right? Very difficult question, guys, right? Understood, guys?
Yes.
Now the third one. In the
Yes,
third
sir.
question, yeah, 0. Okay, so potential energy is minus PE cos theta, right? So minus 3 into 200 and cos of 60. So minus 3, 200 and then half. So this is 100. So minus 300. Yeah, you said 300. Good, good. So minus 300
Yes.
joules. Yes, you are correct, Sharas. Understood, everyone? Please note it down and then we will talk about. So now we have calculated all kinds of potential energy, right? So please note it down, question as well as the answer, and then we'll talk about the next topic. Yeah, whenever you guys want me to scroll down the screen, you guys please just.
Done, sir.
Done. Okay, this part also done. Tarif, Faiza, and Chavez.
Yes, certain.
Okay. Faiza, what about
Yes.
you? Okay, so now we have so this is derivation part is not important. So we have self interaction energy. Self interaction energy, right? So what is that? So self interaction energy of a hollow sphere. So you see that we calculated right. So we calculated the work done in making this charge sit at these corners, right? So some work was done to put all these charges to remain here, right? So that was the potential energy.
Sir.
Similarly, when we put all the charges, right, on the sphere, so we are putting all the charges at the surface, at the hollow sphere, right? So this hollow sphere can be conducting, non-conducting, and for the case of hot solid conducting sphere, right? So what is the energy or the work done which has been done to put all the charges on this sphere, on the surface, that is called the self interaction energy. Clear? Similar to the case of this one, similar
Sir,
to
can
the,
you repeat?
yeah. So what we do is that we put all the charges on this sphere. So there would be some work done in bringing all the charges from infinity to this point, right? Right,
Yes.
Shavis. To put all the charges at the surface, there would be some work done. And that work done is stored in the form of this self-interaction energy or the what we call the potential energy. Understood? Yeah. So this is and the this is equal to this is q square. Let's say the charge is q. So this is q square 8 pi epsilon naught and the radius is r. So this is Is this clear, guys? So this is the self-interaction energy of the hollow sphere. Clear? Yes, guys, clear. And similarly, we have self-interaction energy of a solid sphere. Right, this is non-conducting. Why? Because if this is conducting, then all the charges will reside on the surface. So that is why it is non-conducting. Okay. And for the non-conducting sphere, this is the charge distribution. Right. So due to this solid sphere, the self-interaction energy is 3q square by 20 pi epsilon naught r. Okay, just to remember these formulas. No need to think about the derivation. Please note it down, and then we will do one question based on that. So please note it down. And whenever you guys have noted it down, please tell. Noted, guys. Yes, everyone noted.
Sir, I'm ready.
Yes, sir, noted.
Okay, Faiza, noted. Oh, Faiza is saying, yeah. Okay, so now let us do one question based on this idea. So we have two spheres, right? One is a hollow sphere
Second
with
is fluid.
charge. Oh, yeah. Did you not? Okay, sorry about that. So
Done, sir.
so we have a question, right? We have two sphere. One is hollow sphere with positive charge, and the this its radius is r. And we have another on the same axis, right? On the same axis, we have another sphere. Okay, this one is a solid non-conducting sphere, but it has a negative charge. With a minus q2 charge, right? And the separation between these 2 points are r. Okay, so then we have to calculate what is the potential energy. right? So uh, how many kinds of potential energy would be there?
Sir, Q2 is non-conducting.
Yeah, Q2 is non-conducting. That's why we have inside the sphere we have also the charges, right? Yes, Shah. So this is non-conducting. Q1 is conducting. Did I say conducting at some point?
No.
Oh, yeah. So Q2 is non-conducting. Q1 is conducting. Yeah. So how many interactions would be there? Can you guys tell? How
3.
many? Yeah. So three, right? Three interactions. So we have three interactions. So can you identify what kind of, if I say that I have two kinds of interaction. One is self and the other one is the other interaction. So how many self interaction do I have? Yes, how many self interaction do I have?
2.
Two, right? So we have two self interaction because this one, this one is interacting with itself, right? So these charges are interacting with itself. So this has self interaction energy. Similarly, this one also has self-interaction. Finally, what is happening that why this- yeah, finally, what is happening that these two are also interacting, right? So then we have one other interaction. Understood? So what would be yeah? So what would be the total energy? So this would be q square, q1 square by 8 pi epsilon naught r. And this is again, right. Minus a square is also plus. So 3q2.
Minus.
Yeah, this is square, right? So minus minus is plus by 20 pi epsilon naught r. Right. And then we have this one. So plus k q1 q2, which is minus and then divided by 1. So we have what? We have q1 square by 8 pi epsilon naught r. We have 3q2 square by 20 pi epsilon naught r. And minus, this is 1 by 4 pi epsilon naught, right? So 4 pi epsilon naught r. Is this clear to you guys? Is this,
Yes, sir.
yeah, so please note down from here. And whenever you guys want me to scroll down the screen, guys, please just
Can you scroll down?
Yeah. Completed,
Then
guys. Done. Tarif and Faiza, what about you? Yes. What about you guys?
Yes, completed.
Okay, so writing the last part. Okay, so please note down, Faiza. So done. Now the next thing. Okay, so all the things are done, right? So now let us start about learning about capacity. Right. So uh, you guys in your CBSE portion already did this, right? So what is a capacitor, guys? What is a capacitor?
used to store charges.
Yes, it is a device which is used to store the energy, right? So energy is storing device, right? So it is a device which stores energy, right? So we have, yeah. So I will not talk about the capacitor, right? So in our class, we will talk about three kinds of capacitor, right? So capacitor, right? We have usually three kinds of capacitor. One is the parallel plate capacitor, and then this is a spherical capacitor, and then we have a cylindrical capacitor. So we will talk about these capacitors. Okay, and then we have what capacitance, right? So what is a capacitor? Right. So we know that the charges is directly proportional
Scroll
to,
up.
yeah. So this part we will discuss in detail, Shabbos, right? So I will talk about these.
And
Yeah. So what is a capacitance, right? So we know that charges is directly proportional to voltage, right? So if we remove the proportionality, so this comes, right? So the ratio of charges by volt, this is called the capacity, right? And this is so it does not vary with the charges, it does not vary with the potential. So if we let's say this is capacitance, and we are increasing the charges, right? So this will remain constant, it will not increase. Similarly, if we are increasing the voltage, right, potential, then also it will always be remain constant, right? So this is called the capacity. So the first thing that we will talk about is the So one moment, guys. Yes, guys. Sorry about that. Sorry, guys. Yes, sir. Yes, sir. Okay, so there was an important call and I had to pick it up. Sorry about that. So yeah. So the
Yes,
first, yeah. So first device that we will talk about is the parallel plate capacitor. Right. So you
you can
have.
just scroll up.
Oh, okay. So
Yes,
okay. So yeah, the first device is parallel plate capacitor. Right. So we have two plates. Right. Oh, not this long. We have two plates. Right. And this is connected with positive and this is connected with negative. So this is negative charge and this is positive charge. Right. So we have this capacitor. Okay. And now we want to calculate. So we see that there is nothing inside this capacitor. Right. So you guys tell me, these are two parallel plates. So what is the electric field of the parallel plates? So this is voltage, right? So what is the, let's say if this is positive, so what is the electric field of this? plate. You guys remember? Yes, Tarif, Shaviz, Faiza, we extensively did this problem. So, do you guys remember? Yes. So this is in this direction, right? And in this direction. So electric field is
C is
sigma
equal to
by,
E into A by T.
yes,
There is it E into A by D.
E into A by D. Oh, yeah. So you are
Yes, sir.
talking about the capacitance, which is A E epsilon naught by D. Yeah,
Yeah.
so we will come to that. I'm only asking that electric field, right? So electric field due to this plate, positive plate would be in this direction, which is sigma by 2 epsilon naught, right? And in this direction, sigma by 2 epsilon, right, guys? And we have this negative 1. So we have this negative 1, right? So due to this negative 1, we will have in this direction, right? And in this direction, right? So in this direction, we have sigma by 2 epsilon naught. And in this direction, we have sigma by 2 epsilon naught. And in this direction, we have sigma by 2 epsilon, right? So 3 electric. And for this case also in here, we'll have sigma by 2 epsilon naught. So you guys can see that in this area, this one canceling out. In this area, this one canceling out. And in this region, the electric field is adding up and it is giving sigma by epsilon naught. Right. So this is sigma by epsilon naught, and the distance between these plates is d. Right. So V is how much? V is E into D, right? So E would be, or V is sigma by epsilon naught D. So this is RV, right? And the capacitance is Q by, so this is Q by sigma epsilon naught and T, right? So the sigma is what? Sigma is Q by A, charge density, surface charge density. So this is Q, right? And this is epsilon naught, this is Q by A, and this is, so this cancels, and we have, as Tarif was saying, this is the capacitance of parallel plate capacitor, right? So this is how we calculate the capacitance of a parallel plate capacitor, right, guys? Clear?
So
Yeah. My voice is lagging. Okay. So and then similarly, when we have
Sir, can you
can I
scroll up?
scroll up?
oh yeah. So this you have already done in your CBSE part, right, guys? So I am just revising. Yeah. So whenever you guys want me to scroll down the screen, guys, that
Done.
Done. Okay. So yeah, and then what we do is that, so in our case, there was nothing inside the capacitor. Now what we do is that we place some dielectric medium. Right, we place some dielectric medium of dielectric constant K. So as you guys saw, when we place in Coulomb's law, remember the Coulomb's law, this was 1 by 4 pi epsilon naught Q1 Q2 by R square. So this was when no other dielectric was there. But when we place the dielectric, this changed to what?
Epsilon.
Yeah, absolutely right. So this changes to just epsilon. So similarly, in our case, when we put a dielectric constant, so this C would be, this was, right, this was A E epsilon naught. So this will change to this one, right, which is equal to A epsilon naught and K divided by T. So this is when we put the dielectric constant, right? So when we put dielectric constant. Okay, so this is this is totally filled, right? There is no gap between the plates, right? So the gap is totally filled, right? Okay, so on the basis of this, let us do one question, right? I have 13 minutes, so let me do one question. You already know that, uh, what is the capacitance of this one. Now what we have is that we have a capacitor which is like this. So this one and then this tilted one. So this is the capacitor. Okay. Now we have to find out. Let's say that this is tilted with some angle theta. So this is theta. Okay. And this distance is yeah. So this distance is same as this. This is y naught, and this is also y. Okay. What is one moment? Okay. And we want to calculate, and the area of this dielectric is right. So this area is, or this square side is okay. So this is B and okay, guys. Now we want to calculate what is the capacity. Is this question clear? So we have
Sorry, unmuted.
oh, oh, am I audible now? Yeah, am I audible now? Yes,
Yes, sir.
okay, one moment, guys. Yeah. Okay, so we have this dipole, right? And then this dipole. So you see that these two dipoles are parallel to each other, right? So these are parallel to each other. But now the other dipole is tilted like this. Okay. So this is tilted like this, but they have the same area, right? They have the same area, so same dimension. This is also B and B. This is also B and B. Okay, guys. So how do we calculate the capacitance? How do we calculate the capacitance, guys? Yeah.
Resolution.
Resolution. Okay, so what we can do is that, yeah, so you are nearly correct, Shabir. What we do is that we take, let's say, at some x distance, right? At some x distance, we take a small length, right? Very small length, dx. Okay, and this distance is y. Understood? So this is x and this is y. And what we do is that, yeah, what we do is that, let's say, let me write this as y1. Okay. So the total distance, this distance is, or from here to here, this is y. Okay. So if this is the distance dx, right? So what would be the area of this plate if I take small element dx, right? So what I do is that, okay, one. So in this plate, I have this plate, right? So this was actually this. So it has this one. So this length and this length is A and A. Okay. In this part, okay. So from here you can understand. Yeah. So from here you have this length A and A, right? Now it is tilted, right? So you have this one. Okay, this one is tilted. So how do I? Yeah. Now, yeah, this one. So this is tilted. Now I take a small length element in here, which is dx. So this is dx, and what is this length? This length is what? This length. This length is same,
So
right? A, right? So then what would be the area? What would be
ADX.
ADX? Correct, correct, absolutely correct. Good, good, Shabik. So yeah. So then the capacitance, small element capacitance, this would be epsilon naught dA, small area, divided by this distance from here to here. Why? Am I clear, guys? Am I
Yes.
clear? Is this clear? So this would be epsilon naught, and this is as Chavez said. So dimension is oh, this is B. So dimension is BDX, right? And then Y. So you can see that this Y is Y naught, and then this Y. So Y is, this is BDX Y naught plus Y1. Okay. So this is Y1, right? This is Y1, and then this is dx. So if I want to calculate the capacitance, this is small capacitance. So from small capacitance, how can I calculate the whole capacitance?
Integration.
Integration. Yes, absolutely right. So I integrate it, right? And this becomes, oh, this is epsilon naught. So this is epsilon naught. This B is constant. This is D. And this is Y naught plus Y1, right? So what is the variable it is dependent upon this integral? We are taking the integral with respect to what?
Y.
We are
Sorry,
taking
Y1.
the dx. X is the right. We are taking the integration with respect to x, right? Right, Shavez?
Yes.
So now we
So
have to
here,
write
but y1 is changing, right?
yeah, y1 is changing. Yeah, you are absolutely right. Y1 is changing, right? But the integration is with respect to x. So we'll have to change this y1 in terms of what? Because this, as you change this x, as you are changing this x, your y1 is changing, right? So your y1 is dependent upon this x, right, Shaved? Tarif and Faiza, clear? So
Yes, sir.
you have this y1, right? This y1 and then this x. So whenever you are changing your x, this y1 is changing, right? So your y1 is dependent upon this x, right? And this angle is theta. So from here, can you guys tell me how can I relate this x and y1? How can I relate this x and y1? How can I relate x and y1? Yes, guys. Yes. Any trigonometric ratio that is coming into your mind? What would be tan theta?
Y1 by
Yeah, so tan theta is y1 by x. So I can write y1 as x tan theta, right? And this list distance is what? This is b, right, Shavi? This total is b, right? From here to here, this is b, and from here to here, this is y naught, right? So I can write this y1. So this is epsilon naught b dx divided by y naught plus this is y1, which is x tan theta, right? And I know that this tan theta is equal to this is b and this is y naught. So this is also equal to y naught by b. So this is equal to epsilon naught b dx and y naught plus x into y naught by b. Am I correct, guys? Is this
yes.
correct? Okay, so then it will become what? So then I can take y naught outside and epsilon naught b and y naught outside. So this is dx and then this is what? This is 1 plus x by.
It's to my
Yes, yes. What did you say, Shaved?
nothing.
Yeah. So we have this kind of integral, right? So let's say that if I take b as LCM, right? So this would be how much? Let me write this as okay. So what I do is that I take put what would be the limit of this integration? What is the limit of this integration? X is going from what to what? X is going from what to what? Guys, yes. What is the limit of this integration?
0 to b.
0 to b, right? So it is going from 0 to. Okay, so this is 0 to right. So now put 1 plus x by b equals to, let me say, b. Okay, or you can also write it as t, whatever function you write. So dx by b, this would be equal to dt. So dx is b dt. Is this clear? So I can write epsilon naught b by y naught 0 to, and if 1 plus x by b is t, so if I put x equals to 0, so t is 1, right? So at x equals to 0, t is 1. At
How did we get dx by dp? Dx by b is equal to dt.
yeah, I took the differentiation, right? So d by here and then here, right? So I took the differentiation, d of this and then d of it. So this is constant, so this would be 0, only dx and b is constant again. Not clear?
Yes.
Clear or not clear? Should I?
Yes, got it.
Okay. Okay, so this is b dt, so and at x equals to b, right?
With
This is,
respect to t, you took
yeah, now we change the, so you can see why I am doing that. You can see in a moment, so why I am doing that. At x equals to b, so b by b is 1, so t is 2. Okay. Now this integral changes to 1 to 2, and this is dt by b and then t. So now does this integration help? This is e naught b by y naught b, and b cancel, and we have dt by t 1 to 2. So is this integration does this integration helps?
yes.
Right, so what is the integration of 1 by t? What is the integration of 1 by t? What is 1 by x 1 by x dx?
And x raised to minus and by
This is log x, right? Right,
yes.
guys. So this will become what? This will become e naught by y naught and log of t from 2 to 1. Right. So this is epsilon naught y naught, and then this is right. So this is log of 2 minus of log of 1. So log of 1 is what? This is 0, and then this becomes epsilon naught y naught log of. So this is yours. Okay, did I do any mistake? Because I can find that. Oh, dx is b dt, right? Dx is b dt. So we have, so this is b, and this is b dt. So this is b square, so b square, so b square. This is the answer. Is this clear, guys? Clear? Any doubt? If you guys have any doubt, please ask. Chavez, Tarif, and Faiza.
Sir, can you just explain from that t part
T
where you
part.
took t?
Yeah, so what I know is that I know the integral of 1 by x dx. Right? This I know, right? This is log x,
Yes.
right? So what I do is that I have this complicated integral. I have this integral which is 1 over 1 plus x by b. This kind of integral I have, right? So if I write this as t, so this will become 1 by t, right? So this is simple integral,
Yes.
right? So that is why I put 1 plus x by b equals to t, right? And then I found out that dx would be b dt. So I replace dx and
So
1,
here,
yes?
so here with respect to which you differentiated, like,
Yeah, okay, so this part, okay, what you can also do is in here, right? So you take the differentiation with respect to t. Okay, differentiation with respect to t. So this is one, right? This is one, and this is zero. This is dx by b is taken outside dt. So dx is b dt. Understood, Shavi?
yes, sir.
Yeah. So we can do it this way also. Okay, so I will stop it here. You guys quickly note down, and I will take the question in the next class, right? Because I have a very important work, right? I have to attend somebody at yeah at a few moments, and you guys please note it down. And
Sir, can you just scroll down?
you guys have already noted it down. This part,
No, sir, I have to leave, so I'll just take.
yeah. Oh, which part? Which part, Shavis?
Scroll down more,
Yes.
sir.
Okay, Tarif and Faiza, what about you?
Yes,
Oh,
can you scroll a bit down?
a bit down. Oh, Faiza, you already noted. Okay. Where should I put the screen, Tarif?
A bit down.
Where?
Yes, fine. Yeah.
Okay. Yeah, you already noted down, Faiza. Yeah. And I will explain this again in the next class. So if you guys have any doubt, please ask me in the next class, right? So today I could not talk about yeah in this detail. So in the next class, if you have any doubts, so that I will. Oh, you guys ask and I will explain.